All right, let's start. Can you all hear me? Maybe, let's see. Yes. Right, okay. Let's start. All right, welcome. Thank you for being here today. My talk is about a story about a monolith and a llama. Um, an animal, and it could be a dance between open source and closed and centralized AI system, right? Actually, I could have called the talk "The Planet of the Llamas," but maybe you won't have come. So let's stick with this. Beyond the monolith. So, yes, it's about a llama who is trying to break free from the cloud monolith and get rid of the strains that he has. And you'll see he has a superpower that will prove very useful during the talk. But let's introduce myself. I'm Raphaël Semeteys. My name is pronounced. I'm from France, in Paris. I'm head of tech advocacy at Worldline. Who ever heard about Worldline? Nobody? We're in the payment business. That's enough to say, right? I'm a senior architect. That is something important also when we analyze a complex system. That's what I do. I try to break down things and organize them to understand the complexity. I'm also a certified yoga teacher, and I'm a geek, hence my nickname Yogeek, Raphaël Yogeek, right? So namaste. I'm a geek because I'm in open source for years and years. I design games, and more recently, I started to publish novels, sci-fi novels, with the assistance of AI, but we'll speak about it at the end of the talk. You'll see why, right? Opinions are my own, so they don't represent the positioning or the opinion of my employer, right? And I say that because I think, personally, that today, regarding AI, we are in an intelligence oligopoly, right? Where you have a few companies, a few countries who centralize the power and the power of AI in their hands, and it has a lot of impact on the planet and on the many different aspects that I won't detail there. You heard about it, you thought about it, you know about it, but it's economic issues that are now transforming into geopolitical issues with, predation reflexes that we observe on how to take the resources from other countries to build the AI and create nuclear plants and stuff like that. There are obviously technical issues of dependencies, for instance. We speak a lot about here in Europe about resiliency, sovereignty, that kind of stuff, right? So on who do we depend? And of course, all of that has a huge impact on ecology and on the planet, speaking about resources like energy, but also water and all that kind of stuff, right? So centralized AI seems to me not to be the only way, because it doesn't seem sustainable on the long run, right? So how can open source help to build an AI that we can maybe distribute a little more and have more control upon, right? So let's see if can open source save a super llama, because I told you he has a superpower. And to dive into that, my presentation will be broke down in 3 different parts. The first one is just a refresher about what open means for a model for AI. That was a talk I gave 2 years ago in this very same conference. Then we'll have a look about the AI tech stack when we speak about local AI inference tech stack. What are the different components that we need to have a model running on this PC or in a container on my own server, right? And then we'll move into the world of distributed and even decentralized AI, where the craziness happens, right? So bear with me, and let's start with what openness is in AI. So what's going on? Yes, that's the superpower of Super Llama. He has time travel power, right? So go back the last edition of OCX. I won't do the same talk because there's no point of that. But maybe if you didn't see it, you can scan this QR code and then you'll have access to it. Basically, I'll give you a very, very 101 on that. So I made this talk and I created this talk like before the open source AI definition from the OSI. But basically, that's the same idea there. So that's stack number one, right? To understand and to map the landscape of AI and open AI, right? So I spoke with AI scientists in my company, and I told them, what should I look at when I want to evaluate how open a model is, right? So they told me, OK, look at how it was built, and do you have access to all the components that you need to reproduce this? If you can reproduce it from zero, it means that it's completely open. Scientifically, you can reproduce it, right? So here is a very simplified schema on how models are built. Very, very simplified, right? But here, you have like the big model, foundational models that are trained in a self-supervised pre-training phase. And they're trained on large data set. Basically, they're very hungry. They try to eat everything that we produce. And now they start eating what they produce themselves. So we'll see. The mad cow problem will become a reality. Then, sorry. Then you have here fine-tuned models that you can adapt, you can fine-tune, you can derive. All right, so it looks like open source. You reuse the open source product and then you derive it, you adapt it to your own need. And then for that, you use like another data set with human instructions and responses, for instance, to fine-tune it. And then you can also align it or reinforce it, whether it's based with human feedback or AI feedback now. And you also have another data set here. And I told them, OK, so based on that, when I want to assess the openness of a model, what should I look at? They told me, first thing, the model. And the model is not the code to design the neural network. Every AI scientist knows how to create a transformer stuff, and that's not the point. What we want to know if we have access to the weight. The weight are the result of the training, so basically the configuration of the neural network after the training, right? So knowing the architecture, having the weight, you can reproduce the model. Right? So that's the first thing that you look at, right? And basically, when you have that and only that, that's what we call open weight, right? Then, of course, do you have access to the data, right? Whether it's the big data set or the smaller ones, right? And then, of course, most of the time, when it's reinforced, there is an intermediate model that is called the reward model here. A lot of projects don't really share or speak about it. So if it's available, it's a good sign that it's open and that people really want to share things, share the internal recipe for you to reproduce the experiment, right? And of course, yes, some code, but again, not the code to implement the model itself, the neural network, but the code to do all the process, all the heavy lifting, to prepare the data, prepare the training, et cetera, et cetera. So based on that, I made an analysis of the landscape, and each time I give this particular talk, I update it and stuff. But again, this is not the main subject of this talk. So where do we stand here in 2026? Basically, we can say that we are in the era of open weight, right? So open weight is the new black with two different versions. The first one is restricted open weight. Basically, it means that you have the weight, you can reproduce it, you can even adapt, so you can modify the model, fine-tune it, right? But there are some restrictions, and it's framed by the license. So the license is everything here. So models of this type are Llama, Xuan, certain version of Xuan that from Alibaba, Bloom, for instance, which is a French, well, European, the old one model. But they have some restriction like responsible AI, or basically it is don't do bad things with it. But what is bad? Bad is defined in the license, so you have to read the license before, because you might discover that the definition of bad, especially today, we don't know what bad is anymore, right? The new trend, sorry again, the new trend is permissive open weight. So remove this restriction, so you can do anything you want with it, but you won't have access to the data. The data are still private, right? So it's like, remember permissive copyleft, open source? It's a little bit like the same, right? So here you have models like Gemma, GPT OSS from OpenAI, a certain version of Shren, etc. The actors that you find here are basically the challengers that started this positioning from the early beginning, like Mistral from France, right? Or DeepSeek. And well, the people I call the shovel seller, you know? In the gold rush, the people who make money is people who sell you the shovel, right? So why they do that? Those big tech giants, because they want you to specialize Gemma or even GPT OSS, right? Because at the end of the day, you need resources to make it run, right? So they will give you all the information to specify, to derive it, and to run it, but on their infrastructure possibly, right? So that's a positioning. But of course, at the two extremes, you still have the flagship model from the same ones, for instance, that are close, the more capable models, right? So it's black boxes behind APIs. So here you find Gemini, GPT, 3, etc., 5 now. Muse is interesting. It's a brand new family of models from Meta. So Meta, who started the open weight model movement with Llama, now stopped. With the new family, it's completely closed. No more open way, no more closed, proprietary, right? And on the other side, you still have some projects who are trying to be the most open possible. Most of the time it's in research projects, but not only, where they really try to propose the full reproducibility of their model, right? So it's possible, but it's still rare. So why open? Why open source? I say open because you understood open weight, open source. There's a lot of open source washing or greenwashing today. But anyway, it's interesting. We're in an open source conference. I don't need to go through resilience because you know you have not a single point of a failure of the strategic dependency towards a unique actor. Innovation because you know building in collaboration and within a community is also innovative, let's say, and trust. Who controls the data and who controls the rules about how we build the system, right? Openness also allows optimization and democratization. And that's the way to local AI, actually. You can specialize the model. So you fine-tune a larger model and you specialize for a specific task. So it will become very, very good at doing something very specific. You can reduce the size of the model also with some optimization techniques that we will explain just in a few minutes. And then it means that you can run the models maybe on this laptop, in a container, on your local VPS, on your local enterprise or organization infrastructure, right? So democratization. Just the same as open source, right? And that's the way to the second part, local inference. So I started to analyze what do we need to make a model run and to use them and to exploit it on a PC or in a local architecture, local infrastructure or private infrastructure, right? And because I'm an architect, I always do that kind of things. I started to draw some boxes and layers because there's a lot of names that pops out and you don't know. And I speak with people who are in the hardware part. They don't understand what people are doing in the top level on this part. So the purpose of this second part is just to give you some hints and some global map so you can easily navigate then when you see a new technology, say what kind of solution it is, and where does it stand, and how does it articulate with the others, right? So if we're okay with that, let's move quickly through those different layers with some examples, and just remember what are they providing to the global stack, right? So the first one, hardware. So hardware. Of course, we have open hardware, but we're not there yet, right? We have two different kinds of hardware equipment. When speaking about AI, you have the generic one with CPU and RAM. CPU is for general purpose computing, and the RAM is like for multitasking, right? But you also have specialized hardware that are more adapted for the matrix calculation that is required for inference of artificial intelligence model. Like GPU or TPU, it's more parallel computing, right? And video RAM that is more oriented for performance and bandwidth, right? But on top of this hardware level, then you have this acceleration layer. So it's a piece of software that will translate the instruction of the model to pure instruction to the hardware. So it's an intermediate layer, right? It's optimized. They try to optimize the most of the specific hardware, like for instance GPUs and VRAM. You have different kind of libraries in this category. You have NVIDIA CUDA, that is quite known, but which is not open source, by the way. There is an open source project on top of that is called, what is that? Tensor RT, that is a simplification of CUDA, but the CUDA itself is not open source. And then AMD and Intel with OpenVINO, AMD with ROCm are doing the same kind of thing, but in an open source way, because they're trying to differentiate, because NVIDIA is the leader in this domain, right? So you have this hardware, you have this layer on top of the hardware to optimize things. Then on top of that, we will execute the models. So you remember these open models, we have the architecture, you have the neural network, we have the weights. So how do they run? So that we call inference, right? You have two kinds of frameworks. You have the generic frameworks that are built to do the inference, but also the training and many other AI and machine learning processes, right? So we speak about, like, for instance, PyTorch or PyTorch, so who was a Meta project, and it was donated to the foundation. It's under a BSD license. Or you have TensorFlow from Google, who is under the Apache license, right? They are very, very generic, but then they're not really optimized for inference. And most of them, they're in Python, like PyTorch, right? And then you have a second category of execution layer that is optimized for inference only, right? And most of them, they are in C or C++, so it's a low level. They can have some Python bindings and parts of it, but the core is in C and C++. And there you find a lot of solutions, and specifically in the open source world, you have a project like Llama C++, maybe you heard about it. It's that kind of stuff, right? So it's specialized for inference, and it's very, very efficient and performant because it's doing just that, right? The open source way. Just do one thing, but do it good, and then with the architecture view, we will articulate and compose the solution with different bricks, right? But you also have a VLLM that I will speak about just a little bit later. So you have the inference, the frameworks to do the inference. Then you have the models we spoke about, the open models in part one. They can be optimized for inference. So you have different techniques like pruning. Pruning is a way of removing all the unnecessary weight for what you want to do. So you simplify basically you simplify the neural network. So it's less big, it's smaller. Yes, and then it requires less resources to do the inference. So pruning is one technique. Quantization is reducing the accuracy of the weight. So it's a trade-off between quality and performance. You have also distillation. Distillation is when you take you train a small model that already exists to imitate a larger one that is more capable. And then it's mimicking the large model. So it's called transfer learning. Right? Or you can also have the low rank adaptation, which is an adaptation of existing model, but you just simplify and change the upper layers of the neural network. So you don't have to retrain everything, you just retain just a part of the neural network. And with all these techniques, it's very easy then to fine-tune, to reduce, to adapt existing model, if they are open, to run on a local machine or in a local container, right? And you have a lot of solutions and models that exist in this domain. Some of them are well known, like Gemma, which is an open weight version of Gemini, let's say, by Google. You have Xuan from the Alibaba. You have Mistral that I mentioned, and you have also small language model from like 5.4 from Microsoft, right? When you have the model, so we have this stack, right? The hardware, acceleration layer, the framework, then the model. Then we want to use it. So how to serve the model. And that's another kind of component that serving the models. What they do is beyond providing APIs that the human or the system will be able to consume. By the way, it's done now in a de facto standard that is the OpenAI-like API. right? Even if it's not ISO or it's a de facto standard. They also provide other features like performance with integrated caching or dynamic loading and unloading of the model. So you can load, unload the model based on rules or very easily, right? They also provide features or capacity for developers like batching, streaming the responses, logging everything, some observability features for people to learn and know what's going on, actually. So basically, it's to package the model to be used in an architecture where you will compose it with other things. Right? And here in this domain, you have numerous inference servers, open source. One of them that is known is Ollama. Maybe you heard about it, right? So it offers that, caching, dynamic loading, unloading, and stuff. VLLM is very interesting also, and a very dynamic community doing that. So Ollama is, the license is MIT, VLLM is Apache too. So you see, it's open source and permissive licenses. And there's a lot of different actors contributing, for instance, on VLLM. Right. VLLM is seen like a kind of the new Docker for models. Right. But you also have other inference server like Torch, Serve, Triton, TGI from Hugging Face. And you can also serve your model locally with some desktop application like LM Studio. Maybe you heard about it. Well, it's not open source. It's freeware, let's say. But you have Yan AI that I love. It's a very interesting project coming from the East Asia. They build everything in the open. It's a very powerful solution. So you have a lot of things. So you can serve, you can optimize, and then when you do that, then you start using the model, right? So first by users with users interfaces, and then you have two different kind of users. You have the end users, so they will have their own version of ChatGPT, let's say. So a UX with a prompt, and then I have access to a model. It can be web or desktop based. So I spoke about Yan AI. Thunderbolt, maybe you heard about Mozilla Thunderbolt. It's a brand new project doing just that. You also have integration of the model within the browsers now. We can run some small model within the browsers. There are standards that are emerging regarding this aspect. And you can, and you see in all the tools of every day now, AI is infusing everywhere. You know? So because you can have those specialized model, not that big, you can inject AI everything. AI is injected in my phone now. I can run some models here and stuff. Right? But they're also targeting developers. So for instance, you know Jupyter Notebooks, which are coming from the data science world. Now it's a very, very adopted way of sharing both the code, the result of the code, the execution, but also documentation. And of course, you have a lot, and that's a domain that we spoke about a lot here until today in this conference about coding assistant and AI agents like Thea AI, or Cursor or Open Code, and there's a lot of solutions for developers right now. Okay, so that's how to consume AI itself. Now, how to build system with AI blocks, right? So two layers, you remember? The first one is orchestration and augmentation, and then we'll speak about agentic, right? But first, orchestration and augmentation. Orchestration, basically, you have frameworks like LangChain, whether it's the Python version, the TypeScript, JavaScript version, or the LangChain 4J Java version, right? Or no-code or low-code solution like Flowwise or kind of N8N, but N8N, sorry, to build workflow based on AI. Basically what they do, they help you orchestrate things, including AI blocks like LLMs, agent and stuff. They abstract the model, so it's easy for you to design the system and then change the model, change the building blocks. They also implement the RAG patterns, retrieval augmentation, generation. So they provide a lot of connector to inject your own context within your own data private data within the context, and then let the LLM give you an answer that is more contextual, right? And then here we have a lot of solutions for vector stores. So when you want to do the semantic search that is required most of the time to do the rack pattern, so you have chroma, quadrant, but you also have the usual suspect like Elasticsearch that who added the vector store capacity and semantic search, or even PostgreSQL, right? Who supports that. And because we are speaking about building solutions, distributing things, we need protocols to integrate, right? So tools first with APIs, so how to let the LLMs know about what is the context that he can ask you to ask for him on his behalf, right? But let's say he calls it, even if it's not really the case, right? But again, to grab some new information and inject it in the context for you to have an answer that is relevant to your environment. And now with the new kind of protocol like MCP, that's standardized it, right? So here is the first generation of application that we built with AI component, and then we moved to agentic AI. Agentic AI, so what is an agent? A lot of people have a lot of definition, but basically it's an autonomous program that has a goal that you give him, or maybe another agent gave him, right? And who will be able to plan to achieve this goal, right? You build and we build more and more multi-agent frameworks where you do orchestrate agents and you distribute the task between the different specialized agents. And who says specialized agent? With those SLMs, with a different way of using AI, you can have an agent that is using Gemini, another one that is using 5.4 because they are not doing the same thing, and you don't want to spend the same money or expose the same kind of data because it's private and you want to share it. Right? There's a lot of framework to organize that. Some of them are the evolution of the previous solution, like LangGraph, which is in the LangChain ecosystem. But you also have what's the name? Yeah, AutoGen from Microsoft, ADK from Google, and CrewAI, which is interesting because it's more distributed, and the agents are auto-organizing by discussing between themselves. It's not that there is an orchestrator that is orchestrating everybody. The agents are doing some kind of choreography. They dance together, right? That kind of stuff, right? And for that, you also have new protocols and when you have new protocols emerging in the ecosystem, for me, it means that it's mature, it's maturing, right? Because we need to integrate, so we need the protocols. So we have protocols like MCP we saw, A2A to allow two agents in different technology to exchange and to interact between themselves, or even data format protocol like Tune, optimize. It's more optimized like JSON or CSV. It's token optimized, to exchange the data with models and inject them in the context. And you can also have a specialized protocol. I work in a payment company. There's a lot of things going on right now about how to make sure that we have a standardized way to let the agent make some payment on your behalf. I don't know in which world we'll live in a few months, but there are things going on right there. Okay, so that's the local reference. And when we have this openness, this way of having a way to easily run a model on this very particular box or in a container or in my private infrastructure, then I can do what I do for a long time as an architect, design architecture. And since the internet that we all built together, we know how to distribute things, right? So enter the world of distributed, and we'll see decentralized AI. But let's start with distribution. So distribution, we talked about it, about all the open source framework to do the orchestration, the augmentation, and the agentic workflow now. And as I said, we have some interoperability protocols that are there to help us to do it in a proper way and in a durable way, right? There is also the distribution of the execution itself, so the inference or the training. But let's focus on inference, right? The idea there is to overcome the hardware limitation, all right? Instead of having a big data center in Texas that we will call Colossus and try to build some nuclear plants around it because it requires so much energy, maybe we can distribute things, right? Just like we did with the internet. Right? So there are different techniques to do that. Offloading. Offloading is a way of I'm running something on local, but there is some mechanism that allows me to offload on the cloud. certain task, or just like the scale out of the cloud. And you have solutions like Olama Cloud. No, so the Olama community now is offering this also, a cloud. So they're going on the SaaS business also. But you also have a Docker offload. So you have Docker model runner that allows to run a local model on your PC, and then with the Docker offload, you can offload some of the load on the cloud, and you have other solutions. But you can also have, and for me as an architect, it's interesting to see the pattern of distributed computing. So you start to have some gateway. So Light LLM, for instance, is a smart gateway. So as soon as you have that kind of component, you can build your system, right? So it's a gateway, and then it's smart. So based on some contextual information, it will dispatch your request to this LLM or this other LLM or this other LLM, right? You also have the bus, so the messaging pattern, all right. Okay, so on top of Camel, now with Wanaku, you have this project that is dedicated and specialized about how to exchange between systems, AI systems, but with the bus pattern, right? And then you can also distribute the inference. So it means that the inference won't be done only on one machine, but on several machines, right? And for that, you have LLMD, which is a very, very promising, very dynamic project. So basically, it's the way to distribute the inference of a model on Kubernetes, right? So there is an operator, Kubernetes operator, and everything, right? You also have Ray, which is also very interesting, and it's not only limited to inference, it's also for training, for instance. And then the weights are distributed on different nodes, and then the inference is done, or the training is done on a cluster, right? So we do distribute inference, and we do distribute AI already today. And even the Yama C++ project, which is very community-based, is just about to release, or just have released it, the RPC feature of it, which means that several instances of Yama C++ will be able to collaborate. But this is distribution. So this modularity that we have, we can distribute things. So modularity is about how a system is organized, right? Decentralization, the last part, the most crazy part of this talk now, is not about that. It's about who controls and verifies the system that is distributed, right? So the first one is distribution of task. It's a technical act. And the last one is a distribution of power and trust. It's political. Who controls the system? Who controls the distributed system? That's how some people tried in the past. I don't know if you remember something about like the hype for 3, 4, 5 years ago, right? To decentralize things, right? So, our Super Yama is time traveling again. So now it's 1 year back, 2023. Because in this year, I made a series of talk about how it was urgent for us to re-decentralize the internet, right? It started like when I discovered the internet, and I helped build the internet. We all helped build the internet, at least with our own data, right? It was a very decentralized network. That's how it works. That's how it succeeds, right? Because we had the protocol to do that, the low-level protocol. Then my children, they discovered a very centralized internet with some platform, whether they're business platforms or social platform, that capture all the usage, all the data that is produced on the internet. So I speak about the big tech giant, the Meta, the Google, the Instagram, the whatever. So they decide what are the rules regarding the value that is created by us on their platform, right? And the decentralization and all the decentralization initiatives that we observe with blockchain, with Web3, Web 3.0, all that kind of buzzwords, yes, is about how to create new protocols to make sure that even this value, the rules and the business value, is managed by protocols. So again, that's why I use that, the return of the protocols, right? Now you understand that I was young for the first episode, right? So the pillar of decentralization, and I won't go into crypto and stuff, don't worry, it's not a talk about blockchain and stuff, because everybody will be a little bit overwhelmed. But the pillars, and that's what we'll find in what some projects are trying to do with decentralized network and AI, it's open to all, so it's permissionless. You don't need permission from anybody, because if it is, there is a central body who is distributing the permission, right? You have actual ownership of your own data on your own component, right? And everything, because we don't trust anybody, we don't need, because we do verify everything, right? So that's where you have all the crypto, okay? So a token, and here I don't speak about the AI token, I speak about the crypto token. A good way to understand how useful it is don't think about money, right? Think about value. A token is something that bears some value. The value can be money, the value can be power, like a voting right, for instance, in the decentralized autonomous organization. It can be an incentive, it can be used for something, you know? It's a value. And it's also a programmable tool, the famous smart contract, right? And the token is the basis to implement the key feature of decentralization, which are incentivation. So you play by the rules, you earn some token, right? You cheat, you lose the token, right? Honesty, you can stalk, you can slash the tokens. And consensus, which is the very essential protocol on how the different nodes of a decentralized network do agree of what is the truth, right? That's enough for now, okay? What I want to do, that's the last stack of the last part of this talk, is what about decentralized AI? And then when I opened this Pandora box, I got really dizzy. I mean, there are crazy things going out there. So I close it very fast, and then I say, no. I have to look again, but try to have a map again, right? So as an architect, I did that. We can decentralize compute, the data, the intelligence itself, verification, and action. Let's go through those layers very quickly. Decentralized computing. The idea is to reuse, mutualize existing GPUs, right? Instead of building new GPUs, there's a lot of GPUs out there. Let's mutualize them, right? But how can I trust somebody, I don't know, by using his GPU? And why should I share my own GPU? You remember incentivation, all the token. I don't go through all those fundamental mechanisms of decentralized network. I just want to illustrate with two projects. The first one is IO.net. It's a generic marketplace where anybody, you, can rent your GPU, right? And they say it's minus 30 to 70% less expensive than a centralized solution to rent some GPUs. That's the first example. Another one is Hyper. Hyper is more aiming the enterprises, so they take SLA, they take commitment on security, and they have more homogeneous set of GPUs. They even have some deals with data centers to use and run their GPUs when they're not used, right? But today, yes, we can decentralize the GPUs, and behind that, you have they have their own token, their own incentivization mechanism and stuff to make sure that everybody get the value and redistribute it. Right? So decentralized computing. Then, on top of that, the data, right? What is at stake here is how transparent the data is, how transparent and fair and proven is the sourcing of the data, right? Because we know the guys who took all the value from the internet, they took all the data. Well, we gave them the data. We did write the agreement, and we did agree about that. That's why now they can build AI. I mean, they scrapped the old internet, but they also have a lot of data sets from their own platform, right? So how to make sure that the sourcing of data is fair, right? And how can privacy be respected? How to trace the provenance? We have several projects here. The first one is Grass. Grass is a way to scrap data, but decentralized. It's like, for the end user, it's like an extension in your browser where you can scrap the data and then you get paid on the quality of the data that you just scrapped and that you share with the community. Right? And this ensures freshness of the data also. You have Vana. Vana is more like for privacy. It's a safe where you put your own private data and you decide what are the rules, who can access the data, to do what, and you can share the safe with others, so starting this decentralized autonomous organization, for instance. Right? And you have 0G, which is on-chain storage with high bandwidth and parallelization. So they found a way to distribute the storage on a decentralized network for AI, right? I go quick. I don't need to go in all the details because you'll go too easy. It's just for you to have this global vision, right? Now, decentralized intelligence, right? Improve the value created by models. So it's not only about inference. People who are trying to do that, they want to make sure that when we do decentralized AI, we bring some value to humans, right? So the inference or the training. So how can we reward utility rather than calculation? Calculation is the lower level, right? We're in the level of intelligence. So yes, okay, you did the job, but what is the value? Can I prove that there is some value generated by this AI? One good example of that is the BitTensor ecosystem. Maybe you heard about BitTensor. We could make a 1-hour talk on BitTensor and still don't really understand what is BitTensor. It's a whole ecosystem. It's a Darwinian ecosystem of sub-network running on the blockchain, right? Who has their own objectives. So some sub-networks are for inference, so some are for embeddings, for reasoning, for fine-tuning, for serverless AI, you name it. And between these sub-network, there is the competition based on the token, the incentivization, and all the processes from decentralized AI. But between the sub-networks, you also have a competition, so only the best one will survive. So BitTensor, with all this Darwinian crazy stuff, is trying to let new users emerge to bring some value for AI with decentralization network. I stop here because it's kind of dizzy, right? Another one, maybe simpler, is Prime Intellect. Maybe you heard about Intellect One. Intellect One was a model that was trained on a decentralized heterogeneous set of GPUs. And they use some compression and exchange statistically important elements. So there's a lot of cryptography in all this stuff. Huh? They create their own protocols, as I said, but they were able to train a model on a decentralized infrastructure. Pluralist also is an emerging solution. They create node 0, or node 0, yes. And they have something very interesting that they call multi-party computation, where basically the raw data used for training is not revealed. So it's heavy cryptography also. So you can use some data to train a model in a collective way, but not reveal the data itself. So that's crazy mathematical cryptographic stuff. But there are people doing that, and there is the decentralized autonomous organization dealing about how the project is going and where it's going, right? I will accelerate. So decentralized validation. So you have validation in every layer of the protocol because that's the very essence of decentralized network. But there's also specialized network only for that, for decentralization, validation of things. So it's zero knowledge principle. How can I trust the compute, but I don't trust the compute provider? Two examples there, Aura. Any validator can challenge the work for another node in the decentralized network. So it's optimistic machine learning. But if you get caught, you lose all your tokens, so you lose a lot of value, let's say money, right? Genesis, which is more emerging, is interesting. It's a statistical game. So the more nodes you have, cryptographically, the more difficult it will be to cheat, right? So it's more and more difficult. So, and this is just another layer that you can compose because you understood all the layers that I presented. You can take some part of them and then compose your own solution with that, kind of. Now, the crazy part, decentralized action. So we speak about agentic AI, right? What about agentic decentralized AI? So agents has autonomous economic enterprises because here they have this level of autonomy, they have their wallet. So they have their own token. So they can decide with the token to play the game of the decentralized network, right? So that's another level of autonomy. So how to prepare the machine-to-machine economy? Just two examples to illustrate that. OLAS, who provides some autonomous services like models, tools, agents. They have this consensus protocol that is called proof of action. Prove that the task that was assigned to you as an agent is done. And then when it is, then you get rewarded with a token, right? And then you can have this catalog of agents, whether it's your own, you have a marketplace with your own agent that are deployed on this blockchain, or you have a bazaar where you can rent agents from others or lend your agent to other people, right? And the last one, virtual protocol, is interesting because it's virtual entities that can act autonomously online. So people co-own these agents, and this agent will be able to create social media content, create video, create gaming assets, that kind of stuff. And the people who co-own the agent will share the value that is created by the agent. I don't know if you heard about this woman. Her name is Luna. I think it's from Korea. She has a number of followers that is completely crazy, and it's autonomous. It creates values on the network. Well, value depends on what you find valuable, but some gamers and people in the entertainment industry think that there is value there. So you see the world we're building. That's interesting, kind of crazy stuff. So it moves like it's not an employee that you task with something. It's an enterprise that has a goal. You give us some token and money and autonomy, and then it will try to achieve the goal, but in a decentralized way. And by acting and interacting with other autonomous agents. Kind of easy. Right, to finish and wrap up. Maybe, is it a good idea, Raphaël, to speak about blockchain and AI? I mean, sustainability, you spoke about that at the beginning of the talk. Well, the answer is not that simple. We speak about blockchain, not Bitcoin, which is the worst ever decentralized network energy-wise, right? And it allows also to optimize hardware, existing hardware. So maybe to stop this crazy race that we have, like creates all these geopolitical problems that we observe today, right? It's also a good way, maybe sometimes, to optimize energy, because some protocols will promote the nodes that are cheaper, and they are cheaper because they use energy where it's cheaper to collect, like the green surplus, not in the towns next to the waterfalls and that kind of stuff, right? As an epilogue, it's a little bit dizzy, I know. I went very quick. I hope I gave you some keys to understand what's going on in both local AI, openness, and now decentralized AI. We are next to the cliff, but you know, this Yama has a long neck, so we can all grab it, and he's used to those heights, and he's not scared about that, right? Because that's the proposition of, there's a lot of people who are trying to break down this monolith with distributed architecture, with open stacks, with new protocols, with decentralization principles, with openness. But for me, it's not monolith versus distributed, it's more with. Because, I mean, the world is multicolor, and that's what I like as an architect, to have the choice. And depending on my use case, I said, yes, this one, I'll use a flagship model. But for this particular use case, I'll use this local AI and SLM and stuff. And I will decentralize things maybe in the future if I dare to do that, right? What is the next stack? Physical AI. I mean, AI is autonomous, but can't act on the physical world. There are things going on there already with robotics. We speak about physical agent, mobile revolution, where AI is trained on edge, tiny ML and ambient intelligence. So you have always running, powered by battery of your sensor that is connected to the sensor and is analyzing the signal on the fly, you know, and open robotics. To do that, we need some open models, we need local, and we need distributed to build this world. So just to finish, I asked the llama, I say, you have a superpower. Can you go in the future? Because I'd like to know where we're going with all this craziness with decentralization and stuff. He said, yeah, there are many possible futures. It depends on what you decide to do today and what do you delegate from your own humanity to those systems. And he told me, yes, I can go in 2036. I say, yes, you can, because I wrote a book on that. It's a sci-fi thriller that I co-wrote with the help of AI. You can scan it if you want to see. That's not the case when it's go very well, let me tell you. OK, thank you very much. You can scan this one if you want to stay in touch with me and have more details or more longer explanation of some of the topics that I touched here. Thank you for your attention. I don't know, because I don't have the time here. There's nothing. It's finished. We have time for questions? Yeah. So if you have questions, I know it's a big subject, but as you wish.
My question is regarding the model weights, which are being compiled on the hardware accelerators. Model weights are hardware agnostic, yes? So if we truly want to democratize the local AI, how will the model weight compilation look like on different hardware, like you mentioned?
But that's why you have those frameworks. They do abstract. As soon as you have frameworks, layers in architecture, it's an abstraction. That's why you're able to have PyTorch or TensorFlow or those kind of network. They will abstract the hardware part. And the acceleration layers that I spoke about will abstract also the specifics of NVIDIA, Intel, or AMD GPUs, for instance.
But only
so that's why
for
we can.
the ones which are
Sorry?
open source, like you mentioned, 4 categories, right? Only for the ones which have made their weights public.
Well, when it's closed, you don't know what's in the box. You just don't.
Okay.
Right? Okay, thank you very much.